Good morning, everyone. This is Shravan here. I'm your instructor, and we're going to start the session now. I can see that you guys have actually wanted the session to start around 10:30, but of course, we have been delayed with small, minor technical glitches. And before I start the session, certain things I want to actually set the expectation right with all of you people. This is a session where I'm going to talk about what data science or artificial intelligence is all about. I'm also going to talk about and tell you what your job is going to involve as a data scientist. And lastly, I'll also talk about the skill sets which you need to develop if you want to get a job as a data scientist. And as I'm actually going to introduce myself in the course, one thing which I request all of you, in fact, some of you have already started doing it. There's a Google Sheet which I've shared with all of you in the chat box, right? Please fill in your name and probably your current job and what is your expectation from the session. And it would be great if you can actually fill in even your company details, like which company you work for, in terms of uh, your current job. Just also fill in the company details. And I know some of you could be freshers, so for you guys, just leave it as blank. Second thing which I would like to tell you guys is another thing which we should actually take care in the session is please, I know there's a large team of 48 people actually who have joined over here to this online session. So it will be pretty much cacophonous and it will be noisy if all of you actually unmute yourself and start asking questions. So let us follow a particular way of actually asking questions. I request all of you to ask questions only in the chat box, and if not me, my team will definitely be looking at it. If you are not able to answer the question right there and then because I'm in my flow of presentation, I'll definitely answer the questions after some time. Okay, but I will make sure that I answer all of your questions. Okay. So that is one thing which I request all of you. So please, guys, all of you, please go on mute. And I don't want any one of you to actually, uh, ask your questions through your mic or through voice because that will actually create unnecessary problems here. So I suggest please ask your questions on the chat box. Okay, and I'll be looking at it, and my team will also be looking at it, and we'll ensure that. Yeah, can you go on mute? Whoever has just spoken, because it's quite difficult for me to make out who has actually spoken. All of you, please be on mute, and if not, I'll ask my team members to actually put you guys on mute. Right? Okay. So we'll start off the session. As you obviously, I may not actually introduce each and every one of you because of 48 of 49 of you, but please do fill in up. And maybe I will just talk about some of your profiles, okay? Because in the interest of time, so that people are aware, like what is the the kind of audience who have joined to this entire session. So let's start off the session. And can you guys see my screen? I just want one of you to say yes. I can see your screen. Can you guys see my screen? I have a slideshow over here. One of you can actually just show me that you guys can see my screen. Okay, thank you.
Yeah, we can see your screen.
Thank you. And please go on mute. And yeah, we will start with the slideshow mode now. Yes. So this is an orientation workshop for the foundation and advanced course in data science. But before I talk about the course, a little bit of introduction to ourselves as a group, which is Prime Classes, right? So Prime Classes is actually a classroom training and an online training institute, and we are an institute which is being started by actual practitioners, and these are people like myself. My name is Shravan Chaitanya. Like I have worked in the AI and the data science space. If you look at even the other people who are actually part of Prime, like Rameshwar or Sai or anyone, all are actually industry level practitioners, and we are running startups on our own. Okay, I have my own startup called Spike Info Solutions, which is into AI and blockchain, and the other founders of Prime Classes are also into startups. Like Rameshwar is an expert on digital marketing. Myself, I'm an expert on AI. My co-founder will also be teaching. He's an expert on blockchain, and all of us have actually built real-time solutions. And coming to myself, I have been involved in building real-time solutions in AI, especially right for smaller companies to large Fortune 500 companies. And some of my clientele whom I've actually worked with include Nestle, Pepsi, Vodafone, and we have actually built data science solutions for all these companies, right? So one big advantage of actually doing anything with us, which we would like to, which we think is the biggest differentiator, is we come from actual industry expertise, and we have done this in the past. And if you look at my profile, I've been involved in this industry right from 2007, right? And I've been involved in this industry of AI in a variety of roles. And I have been in a role of a developer, I've been in a role of a project manager, I've been in a role of even an account manager, I've even done sales for AI. So I've seen AI from different perspectives, both from a delivery perspective and also from a sales perspective. So obviously we want the session to be as interactive as possible, but as I mentioned earlier, all of you please go on mute because I do hear some background noise. And be on mute and please only ask your questions in the question answer box. And even if I'm not able to cover your question right at that instant when you ask the question, I will ensure that I get back to you during the times when I'm actually pausing between my slides. And I'm able to give the correct answer to you. So let us make it interactive. And all of you, this is going to go on for the next 2 hours. Okay, so that is so right now the time is at in my clock it is 11:05. Okay, hopefully the same what you have in your clock as well. So hopefully we conclude by 1:05 or 1 o'clock. Okay, so keep yourself blocked over there. And a big thank you for coming and attending this session on a Saturday because I do understand that all of you have your busy schedules and both in your personal side and professional side, but you took out time to actually join this. And guys, go on mute again. Okay, this is something which I'm going to repeat many times. Sorry, I'm going to sound like a tape recorder, saying the same thing again and again. But just I want to emphasize again and again the importance of you guys. Okay. So in between, I would even ask you guys some questions, and I would like some interaction because especially when you're doing an online session, there is no way in which an instructor can actually make out what is the interest levels of the audience or whether the audience are actually able to understand what's happening. So the only way you guys can actually do that is to make it interactive and keep affirming in the chat box that you understood or you keep asking questions. That's the only way to go about this. Okay. So hopefully all of you guys are clear on the way we are going to conduct the session. And if anyone has any doubts on how we are conducting the session, please do ask me. Okay. And looking at some of the people who have actually filled in, I see 45 people there in the attendance. In fact, 55 people, sorry. But I see very few of you are filled up. But I leave it to you guys. It's good if you guys fill up. And you guys tell me about the expectation. I can fine tune my presentation accordingly. But it looks like most of the people are coming from either full stack development. Some of them are coming from a business analysis background. Okay. Some are even freshers over here. I think they just, when I say freshers, I'm assuming that they've just passed their engineering or they're in the final years of engineering. So those are the people who have put their expectation. And people, some of them has put an expectation. Okay, someone is saying he's not getting my voice clearly. Are all of you not getting my voice clearly? Is my voice clear enough? Yeah, someone is saying clear, so probably Achal, I think it's you who said that you're not getting your voice clearly. I suggest that you just log off and log in back or check with your internet connectivity. We'll see that. And coming to the expectation, obviously some people are saying that we want to know about machine learning. Some people are giving the expectation that they want to start with machine learning. And some are giving the expectation that they want to switch from Java to machine learning, right? So people want to, the biggest crux is, I'm sure the marketing folks have told you is a machine learning thing, but of course, machine learning according to me is a subset of data science. I'll tell you what exactly it is, right? So machine learning will of course be covering 60 to 70% of the course, but I'll also be covering other basic aspects such as data handling, data pre-processing, and visualization and business analysis also as part of this course so that it makes you complete as a data scientist. Okay, we have Abdul Qadir here who also has a question, and he comes from a BSc Statistics and MBA background, and he has worked in Tata Business Support, and he wants to know if this is suitable for him. I'm sure, like Abdul, many of you guys will have a similar kind of question whether this course is suitable for you, and hopefully I'll be able to answer your questions on this. And then we have Vishal. I think Vishal is asking which ID will I use to train the data on data science. Okay, predominantly Vishal, for a large part of this course, we'll be using R to actually teach you. So R will do it in R Studio, and text pre-processing. Okay, when we reach there, we will be using Python, so we can use Python Jupyter notebooks or PyCharm. Okay, hopefully that answers your question. Those of you who do not understand my answer, that's fine, because it's okay if you do not understand. And we will get on with the session right now. And okay, I do hear a lot of complaints and a lot of noise. So guys, please, in the interest of the greater good over here, I suggest all of you to go on mute, please and please. And in fact, let me see if I can mute all of you and only I can speak for now. Looks like, yeah, looks like everyone on mute. Are you still hearing some noise, people? Okay, yes. Kirti and Shailesh are saying a lot of noise, but hopefully you guys are not hearing any noise, because I do see everyone on mute right now. And please be on mute, and hopefully the people who join late, they will also continue to be on mute. Okay, so let us make this a productive session. I know this is an online session with and Vignesh, please go on mute. Let me mute you. I think Vignesh was on unmuted here. Let me check anyone else who was. Yeah, everyone else on mute. I know this is quite a challenge to actually talk to 52 audiences over here. Obviously, my team are also young and enterprising, and they've come up with a session with 52 audience. So just to make the session more productive and good, again, please go on mute, all of you, and do ask your questions only in the chat box. Don't unmute yourself and ask. And you can also put in your question or expectation even in the Google Drive, Google document which I've shared. Those of you who have arrived late, I'm again sharing the Google document again, so you can actually fill it over here. Your question and your expectation, you can fill it up, and I will look into the Google document. May not be right at that instant because I'll be in the flow of my presentation, but I'll do it as and when required. Yeah, but I'll make sure that I answer all your questions. So that's how it's going to be. So let us not delay any further. Okay, we are going to let us start the session now. Okay, so let's go into slideshow mode again. And very big thank you for considering Prime and actually attending this session. And thanks once again for taking your time on a Saturday and coming and attending the session online. And also being patient, because I think it was communicated to you guys we'll start at 10:30, but we started at 11. Partly the fault is on my side because I came in at 10:40. Apologies once again. And partly we had some technical glitches here, and that it typically happens. I'm sure in future that won't happen. And thank you once again for coming to the session. Okay, objective of the foundation and the advanced course of data science. Okay, first and foremost, obviously this course will, and also this session will actually tell you what are the insights on the role of a data scientist, what do you need to do as a data scientist. Second, this will also help you to analyze data. See, before being a data scientist, before even doing the machine learning, I'll tell you what machine learning is all about. You guys need to have basic analysis bent of mind, okay? And you need to have this inherent skill set, which is both an art and a science, on how to analyze data. Okay, so that's what is super critical. We will ensure that you guys are, if you do this course, you guys actually pick up that. Some of you, as part of your current job, as business analysts, database analysts, or even software developers, could be doing this to some limited extent already. Okay, so it could be an extension for you guys, or a much stronger foundation. But this is something which we will ensure that you guys are very good at the end of this course. Third, of course, we'll teach you the techniques and tools to transform data. Okay, all this magic of AI and machine learning only happens after you actually prepare the data in a particular format, and you need to actually input data in a particular format. But just so happens in a real-time scenario, data may not always come to you in the most likable format in which you can actually start doing your machine learning. So super critical that you learn the tools and techniques to transform this, and actually before you actually do all the fancy things like machine learning or AI. Okay, so we teach you all that, and then we will talk about machine learning algorithms, and we'll go through all the length and breadth of machine learning algorithms. We'll start off, these are some of the buzzwords, I'm sure you have heard about it. We'll start off with something as basic.
Voice now.
Yes, something actually. speaking. So can you go on mute whoever is speaking, and then give me a question in the. If you have a question, please type in the chat box, guys. Let me just see if I can. Everyone are muted. I think it's GRAFX. I don't know who that is, but I'm muting you for now. Okay, please don't mind. I have to mute you in the greater interest of the class, and do ask your question in the question and the chat box. Okay. In the meantime, of course, some of you are jumping with your questions. Irfan has a question whether MBA fresh is applicable. Yes, Irfan, but I'll tell you the details about it. Just hold on to the question, and you can definitely do it. And let me just go with my flow of my presentation. And so we'll also teach you the machine learning algorithms. So we will go with something as basic as old, I won't say basic, but some old machine learning techniques like linear regression, which were conceptualized in the early part of the 19th century. And we will also go into other machine learning algorithms like decision trees, support vector machines, neural networks. And towards the end, we'll also give you a very good hands-on foundation on the deep learning frameworks, natural language processing, text minings, and all this. So we will cover the length and breadth of all the machine learning algorithms. Okay, some of them in a lot more depth, and some of them obviously something like a natural language processing or a deep learning. These are complete courses in itself. Okay, we will give you all the foundation for this, but deep learning itself is another 10 or 12 session course. A natural language processing another 10 or 12 session course. But this course will give you a strong foundation for you guys to explore even those techniques as well. Okay. And lastly, once you are actually a data scientist, you should have this art of actually presenting your insights uh, and presenting your insights in the right manner to the decision makers. And decision makers are typically business users who do not invest in IT. So how to visualize your data and present your insights, we'll also talk about that. Okay. There is one course question which came now. I would like to take this question. This is from Vivek. And Vivek is asking, is there any blockchain course? Yes, there is a blockchain course, but today's session is more like an orientation session for the machine learning and the data science course, Vivek. But there is a blockchain course which we will also be introducing subsequently. Okay, like just to give you another, just a small two-line introduction, because I gave introduction to Prime classes earlier. Prime classes is actually a collaborative institute which is actually conceptualized by people who are industry experts who have come together and who are actually teaching as a part-time hobby and passion. Okay, we typically teach on either on weekends, or we actually teach on probably in the morning sessions on weekdays, but just definitely before 10 o'clock. So we have industry experts, people who have actually done blockchain. We have industry experts who have actually done data science. I'm a data science and AI expert. We have people who have even have done data analysis. Okay. So we also have people who are giving you foundation courses on Python and Java and other courses as well. So this is something which we all have come together and doing it. And of course, there's another two other questions. I think Vishal and Vignesh. Vishal is saying everybody is talking about AI, machine and data science. Knowledge is enough to call yourself an AI developer. Uh, you can call yourself an AI developer, but I believe that you're a complete AI developer if you have both knowledge and some practical implementation as well. Okay. And then we have Vignesh, who's also done his MTech from information technology. He's talking about internships in networking company. Is it possible to develop career in data science? Yes, Vignesh, it is possible to develop a career as data scientist, and he's doing an internship. But let me, some of these questions I'll touch upon towards the later part of my slides. So now let us actually go forward in my slides and tell you what data science is all about. Okay. Oh, why is the slide not changing? Yeah. So what is data science? And I'll tell you what machine learning is also, Tanu. Just hold on to that question. And data science, the goal of data science is a very old definition which is there in Wikipedia. It may not be in the current version of Wikipedia, because as you guys know, Wikipedia keeps updating its pages. So goal of data science is, or what is data science is, if I can read from the slide, the goal is in extracting meaning from data and creating data products, and seeks to use all available and relevant information to effectively tell a story that can be easily understood by non-practitioners. Okay, the key word over here is non-practitioners, because what you do data science and you need to generate insights based on data science. And please understand, you are doing data science with the purpose of business, okay, of bringing out a business outcome. Business outcomes, okay, those of you, my MBA friends who are actually part of the session, you realize this better, and you also realize why this is an actual extension for you guys. Business outcome is either improvement of revenue, business outcome is either decrease in cost, or a business outcome is improvement in efficiency in the way you do the processes. Okay, so people who are involved in either revenue outcomes, which is the sales and marketing team, or people who are involved in reducing the cost, which is your delivery teams or production teams or manufacturing teams or supply chain teams, or people who are improving the efficiency, again the manufacturing supply chains. Okay, all these people, they are users of IT, but they are not people who actually have knowledge to build IT systems, right? Okay, they do not have knowledge to build IT systems. Correct? So they do not understand data science the way you would be able to understand. These are people who only understand business outcomes. So unless your data science project can actually bring out some business outcome, there's no point for you to do the data science. Okay? And when you're going to bring out the business outcome, you should actually use all the available and relevant information which is there with you guys. Okay? And when I say all the available and relevant information, this is info. Guys, I think one of you has actually switched on your webcam. Can you guys switch off your webcam, please? Because this actually affects our bandwidth. Yeah, thank you. So, when I say all relevant data and information, this is data information not just internal to the company, because internal to the company, some of you are working or some of you are business analysts can actually understand this. Someone like a company like Maruti Motors, okay, Maruti, they have all their enterprise resource planning data on the SAP, which is the movement of cars, the sale of cars, how customers are coming to the service station, they have all their internal data, okay? But they will not have data which is external to them, okay? External data is data which is probably Twitter data. You know, people are talking about bad feedback about the car. Okay, external data could be, you know, the number of registrations which are happening, you know, in the city of Hyderabad or a particular high density market like Delhi, which is like car registration data. So there could be always a scope of extending the company's internal data with the third-party databases. And essentially, this third-party data may not be structured data. Okay, when I say structured data, okay, I'm using a lot of terms, some of it could be new to some of you guys, is, okay. Naveen Kumar is saying he's not able to hear me, he wants me to increase the volume. Are others also not able to hear me, or is it a problem very specific to Naveen? Can any of you just tell me if you want me to increase the volume? Okay. Volume is okay, low it says. So Naveen, please check your speakers and mic. And my internet connectivity is also pretty good. Okay, vacuum like sound coming. Okay, just continue. Some people are saying just continue. Okay, we'll just continue right now. Okay. So extending the company's database may not be always structured data. Structured data is data which is coming from SQL databases. Okay, SQL databases, which is nice tabular data where data has a row ID. And guys, please go on mute, please. I think the vacuum kind of noise could be coming because of some of you are actually speaking or not gone on mute. Okay, and I don't want interruptions, guys, because I'm going with the flow over here. Okay, structured data is data which comes from SQL databases, and this is data which is columnar, which is data, we know each column has a name, and there's a row ID, and it's a tabular data. And typically company databases are structural in nature because they could be using a SQL server or any form of a SQL server to actually store the data. But when you extend the company's database with third-party data, the third-party data or the external data need not be structured. Okay, like as you guys know, Twitter data is actually going to be unstructured data in the form of text. Am I right? So sometimes you may also extend your data through probably semi-structured data. Semi-structured data is data which is coming in the form of JSON and XML. Okay, this is another terminology. Probably you can just stick it out. JSON and XML is data which is going to come in through web services. Okay, this is when machines talk to each other, they share data, or you can extract data from a system through JSON XML. So JSON is essentially a key value pair. So sometimes you may have to combine a structured database with a third-party database, which is semi-structured. So all these are something which you have to do as a data scientist. After you combine this data, the next thing which you need to do is you have to analyze the data. And analysis doesn't have to be something fancy like machine learning. Okay, it can be something very simple as doing basic visualization. It can be something as simple as finding some basic summary statistics. When I say summary statistics, it could be like finding mean, okay, mean or average, which you guys are aware of. I'm sure all of you are. Then something like median, something like mode, okay, and coming up with some intuition about the data, coming up with some insights on the data based on just simple analysis. Post this analysis, right, you can actually say like, okay, Manasa is saying she can't hear anything. Is the same with others also? I feel my connectivity is very good. Probably Manasa, it's only with you. Okay, I think others can actually hear me. Okay, so I'll just reply to Manasa. This is only with you. Check your internet. Okay, right? So after analyzing the data, you actually go ahead and you decide to build a machine learning model if required. Okay, you should not really build a machine learning model where it's not required. You go ahead and build a machine learning model. I'll tell you what machine learning models are, and you guys will also know what is the difference between machine learning, data science, AI, business analysis, data analysis. All these are terminologies which you actually hear, because I know some of you have asked about data analysis already. I'll tell you what is the difference in all these. Okay. So you go ahead and build a machine learning model, and after that you generate some insights. And again, you need to present these insights in a form which can be understood by non-practitioners. So these guys understand charts, these guys understand a data story. So you need to be able to communicate your results in that format. Okay, so that's super critical. So please, in this definition, the keyword is non-practitioners, and the second keyword over here is using all and relevant data. When I say all and relevant data, the data need not be internal to the company. It can also be data external to the company. It can be third-party data which you have to procure. Okay, you have to combine all this data, analyze it, and generate insights. After analysis, you believe you can actually give a futuristic or predictive result using machine learning. It makes sense for the business use case. You go ahead and do that. So your job as a data scientist encompasses all these tasks. Okay. Let's go to the next slide. Somehow, this slide changing doesn't look that great. So if you look at from a skill set, and from a skill set perspective, you as a data scientist, you need to develop these skill sets. You need to develop some programming expertise, okay, which is super critical. And when I say programming expertise, I'm not saying you need to be an ace in programming and you need to be very good in programming, but you need to, on a scale of 1 to 10, this is my personal opinion, even if you're a 6 or a 7 or a 5, you're good enough to be a data scientist. Okay. Also at the same time, another thing which I would like to point out to you guys is, like, there will be, I'm sure in this audience, some of you who have not done any programming at all, correct? So those of you who have not done any programming at all can also join this course, and you can pick up programming as part of this course. And as part of this course, we do teach you R in detail, and some of you, if you want to pick up Python parallelly, we can arrange Python parallel as a different course, and you can pick it up. And but the key important point over here is you should not run away from the idea of programming. Okay, if you're someone who says, hey, I have this mental block, I cannot do programming, then data science is not meant for you. Okay, because I know there are some folks like that. Some people, I've had some folks who are pretty senior in the industry, probably reached in the mid 40s. They have done programming in the past, but right now they're not so comfortable with the idea of programming. So you need to be comfortable with the idea of programming. Even if you don't know programming, it's fine. Even if you're not doing programming in your current job, it's fine. But you should not be averse to the idea of programming again, because some amount of programming is required, and I won't say some amount, a good amount of programming is required, but you need not be an expert in programming. Okay, so programming expertise is something which is critical. You need to understand. The second skill set which you need to develop is your maths and stat skills. When I say maths and stat skills, you need to develop maths and stat skills specifically to these topics. When I say probability and statistics, linear algebra, some amount of coordinate geometry, and some amount of calculus. Okay, and mind you, guys, I will be actually, if you people towards the end of my course believe that my course is very much mathematical intensive, right? So if you guys do not have a good understanding of mathematics, don't worry. The moment you come to this course, you can actually pick up the mathematics again. Okay, I will be going in detail on the probability and statistics, and I will be going in detail in all the concepts of linear algebra which are required for you to be a data scientist. These are concepts such as matrices, matrix algebra, some fundamental concepts of linear algebra. I'll be again talking about it. And I'll also be touching about some little bit on calculus, and wherever possible, we will actually even cover coordinate geometry. Okay, Kirti is asking a question. What to be learned in maths, please repeat. Okay, Kirti, you need to learn probability and statistics. When I say learn, you don't have to learn on your own. We will teach you as part of this course. Please, guys, keep that in mind. We are teaching you as part of this course because as a data scientist, what differentiates a good data scientist from a data scientist who blindly applies the algorithms, because coding a data science machine learning algorithm is very easy. You know, it's very easy. It's very trivial. It's just 2 or 3 lines of code. Okay, what differentiates them is the understanding of mathematics. So in mathematics, we will be covering probability and statistics, linear algebra, coordinate geometry to a limited extent, and calculus to a limited extent. So Kirti, hopefully you have understood and what I had to say. Okay. So if you look at machine learning, really is just your programming knowledge and your maths and stats. So that is your machine learning. And as a data scientist, if you want to really be successful, and I believe that my success as a data scientist comes because I come from a, okay, voice is not clear, this is graphics. I hope others can hear my voice because I see my signal is full. Okay, it should be pretty good. Okay, I don't see problem with the voice. Just check your internet connectivity, guys. Who all have problem with the voice? Okay, so if you look at business knowledge, is what actually differentiates me from my other data scientist peers, because I have done a BTech and an MBA, and I come from a very strong business background. Because I am actually able to translate my business knowledge and into insights easily, and also I'm able to translate. Okay, just a minute. Hold on, guys. Okay, is my voice clear, guys? Just want to check once again. Can you graphics and Preetham say it's clear? Okay, Vignesh's signal from broadcasting is good. Okay, so I just wanted to do a small quick check. My voice is good. Okay, so let's proceed further, and I think it should be better now. And business knowledge is very important. And business knowledge, when I actually say business knowledge, I don't mean business knowledge that you need to know the domain very good, completely. Yeah, okay, now it's good. Okay, I didn't know actually what I did. Initially, these guys, these prime classes, the operations team, they actually made me plug in a mic to my computer and then I was speaking on that. But now I remove the mic and I'm speaking directly into the computer. Okay, I'm using the default mic. This looks much better because GoTo actually syncs well with that. This mic, you should never do it. I'll actually tell them that. Okay, going ahead, business knowledge is not that you need to know the domain really well. Okay, but when you start off on a data science initiative, you actually, you know, what you need to do is, let's say you are part of some company like Infosys, you're part of some company like Wipro. Okay, your client is a banking domain, and you are specifically engaging in the retail banking domain. And when I say retail banking, it is that part of banking, you know, which deals with giving of loans, personal loans, home loans, and all that, right? So if you are going to actually build a data science initiative for them, it's super critical that you understand little bit how retail banking works. You should know how a personal loan is given. You should know what a home loan product is. You should know a little bit about how customers really prospect a home loan product. Okay, this is not something which you need to develop and you need to know beforehand itself. But when you start off the initiative, you should have this inquisitive set of mind to ask the right set of questions to get the right kind of information from your sponsor or your customer, and you should be having an intuitive set of mind to actually research on the domain on your own on Google or secondary research and get the right information. Okay, please understand the role is known as data scientist. Okay, the word scientist means it's going to be very research oriented, and you have to really actually dig up information from multiple sources before even actually delivering some insights. So it's your job required, it's you to actually research a lot, read a lot, collect information, and generate information, and then generate insights. So keep that in mind. It's not going to be a job where you use computer. It's not going to be a job where, as a data scientist, it's going to be a flowchart kind of an approach where it's a flowchart kind of approach. Step one, you do this. Step two, you do this. Step three. It's not going to be like that. It's going to be very subjective. That's why data science is both an art and a science. Okay. And just another thing which I want to explain. Hopefully, I'm going to draw something on the board just to explain what is the difference between data science, machine learning, and all this terminology which you keep hearing in the market. So, guys, if my drawing is not clear, I'll actually read it out. So, hopefully, do let me know if some of you are not able to understand the drawing. Let us assume data science is a huge set like this. Okay. And I do hear some static noise. So, those of you who are on mute, please unmute yourself. Sorry, those of you who are unmuted, please mute yourself. And I think this is Praveen Kumar. Let me mute you. Please don't unmute yourself, please. And I also see someone called caller 1 here. I don't know who that is. Caller 1, please mute yourself on your phone. Okay? Otherwise, I'll be forced to dismiss you guys. I don't care. Okay? If you guys don't mute yourself, I'll forcefully drop you guys from the meeting. So please mute yourself, all of you. So now let us assume data science is a set like this, like a set, right? And today, probably another synonym, another word for data science is AI. Okay, AI or data science are synonyms. AI is artificial intelligence. They're synonyms. And what does it mean? And of course, AI is using a lot of machine learning, predictive analytics, and certain class of algorithms known as deep learning algorithms. Okay, so AI is all about those. Jay Prakash, I think you have unmuted yourself. Let me mute you, please. Please, guys, mute yourself. This is actually creating a lot of disturbance for me, and it is affecting the flow of my presentation. And if you guys keep affecting the flow of presentation, I'll have to go beyond 1 o'clock. Okay? And again, you guys will complain that, hey, things are unorganized and we went beyond 2 hours of slot. So guys, let's make this a joint effort, and please mute yourself. I don't need to repeat myself again and again. All of you are educated adults, okay, who are more than 20 years, so please. Okay, so data science and AI are synonyms. Okay, AI is typically a term which is actually picking up now. Okay, if you look at my experience in 2007 when I started this field, we used to call this field more data analytics or business analytics in 2007. Right? The word data science became popular in 2010 to 2012, and the word AI is becoming popular in the last 3 years. So AI and data science are synonyms. And what are the skills which you need to have as a data scientist or AI? You need to develop some data analysis skills. Okay, someone was asking me about data analysis. I don't remember the name, but data analysis is a subset of data science. And what is data analysis? Data analysis involves some data visualization. Okay, data visualization and data science is a common area. But there is also some data analysis which you do without data visualization, which could be like figuring out the statistical parameters such as mean, median, mode, to give you an example. So data analysis, data visualizations are subsets of data science, and you are going to learn that as part of this course. Some of you would be aware of it, but you're going to learn it again. And then another skill set is data pre-processing or data transformation. Okay? Those of you, I think some of you are coming from ETL background. So you will understand how to extract data, how to transform data, how to load data. Okay, that's something part of it. And you also understand data pre-processing from the machine learning perspective. Okay, you need to prepare data in a particular format. You need to transform data in a particular format. And when I say from a machine learning perspective, there is something like how do you handle missing values. There is something like how do you handle something known as outliers. Okay, an outlier is any point which has an extremely high value or extremely low value. For example, to give you a use case, I'm actually building a data science project to actually predict who will be my people who will take a personal loan. And I know my personal loan is for salaried people, and it's meant for salaried people who are earning a salary of 2 lakhs per annum to 20 lakhs per annum. So in this kind of scenario, let's say I get someone like Vijay Malia who has a lot of income, right, and who has a lot of money in the savings bank account, he will be an outlier for my analysis. Okay, so how do you handle outliers? Again, part of data pre-processing from the statistics or data science perspective, which you need to pick up, right? And then there's a big circle over here called machine learning. Okay, machine learning is part of the bigger circle, guys. Okay, so machine learning is also data science. Please keep that in mind. And what is machine learning? Machine learning is all about finding out patterns using some mathematical functions. Okay, ultimately, we have some machine learning algorithms, to name a few, like linear regression, decision trees, which have a mathematical framework of finding out a function. And when I say finding out a function, all of you mathematically, you know y is equal to, we can express y as a function of x. And let's assume it's not one x, there are many x's. Okay? And to give you a practical example, I want to predict whether a customer is going to take a personal loan or not. So y is that variable which indicates whether he's going to take the personal loan or not. So y will take two values. It can take either 1 or it can take 0. 1 corresponds to that case where the customer accepts a personal loan, 0 corresponds to that case where the customer does not accept a personal loan. And you would like to build this function, and you know functions are nothing but some mathematical formula, right? The popular function which we have come across in our class 10 mathematics is y is equal to mx plus c, right? Where m is the slope and c is the interceptor, correct? So it may not be something so simple like y is equal to mx plus c, but mind you, this is a very powerful function called a linear class of functions, which we will use predominantly in machine learning. But essentially, you could also build a non-linear function. So we are building y as a function of x1 and x2. And if you go back to this example of where y is nothing but the variable where a customer is going to respond or take a personal loan or not take a personal loan, the x1, x2 could be different variables such as savings bank account balance, credit card outstanding. Okay, it could be something like which class of company does he belong to? Does he belong to class 1 category of company, which is Infosys and this, or does he belong to a startup, which is class 3 or class 4? Which location is he from? What is his age? Okay, age, income, saving accounts balance, credit card outstanding, credit card payments. All this could be a different x's, x1, x2, and so on. And you're predicting y as a function of these x's. So machine learning is all about constructing this function. Okay. So now you understand why machine learning is going to be mathematically intensive. So whenever we come up with this mathematics, it needs to be, the mathematics is going to be used underlying, is going to be a lot of probability, a lot of statistics, and I will take you through these refreshes again. There will be some good amount of linear algebra, there will be some amount of coordinate geometry, and of course there will be a little bit of calculus. So that's what we will really cover. So all of you are clear what data science is and how data science is different from data analysis, data pre-processing, data visualization, machine learning. Another term which probably you guys would have heard is business analysis. Business analysis is nothing but data analysis itself. So business analysis is also going to be part of data science. Another subset over here. Okay. So business analysis is actually analyzing data from the business perspective. That's all. There's no clearly any definition to it. So all this encompasses the greater term of data science. Okay. The word AI has actually become popular because today we have certain machine learning algorithms which mimic human behavior, and these are deep learning algorithms. When I say deep learning, these are special cases of a machine learning algorithm known as neural networks. Okay. So when they mimic human behavior, I don't mean they exactly mimic human behavior in the way that human brain functions, but it actually is able to get similar kind of accuracies like the human brain. Okay, especially the human brain perspective. All of you know the visual cortex. Visual cortex is that part of our brain which helps us to detect objects. Okay, it is connected to our eyes, so we are able to detect what is a camera, what is a phone, what is a TV, what is a car, what is a person. And machines are actually starting to do that. So with deep learning coming in, that is actually being possible. And human intelligence is very complex, as you guys all know. Human intelligence, because that's also another research area of mine, which is computational neurosciences. So if you look at human intelligence is function of deterministic intelligence because we do have certain rules in our mind on the basis of which we function. Human intelligence is very probabilistic in nature, which is what we call as wisdom, right? Because all our elders will say like, hey, don't go out in the night after 10 o'clock, you'll be in trouble. That's a probabilistic thing. We know we will not fall in trouble, but they believe that based on some belief system which they have built in their brains based on either their own experiences or they would have done it based on what has been taught to them by their parents or by their teachers. So that's probabilistic intelligence. Human intelligence is also about natural language understanding. Okay, what distinguishes human beings from other species over here is not the deterministic intelligence, it's not the probabilistic, it's natural language understanding. So we, as a kid, we are able to detect, learn languages and replicate, generate languages also, which a machine is never able to do it. So human intelligence is a function of all this, and as part of people who are researching the AI space, we are using data science, machine learning to replicate some of this. And we will not get into that part of research. We'll talk about some of the well-known machine learning algorithms which are being utilized in the business world very actively today, which will actually help you to position yourself or lay the foundation for you as a data scientist. Okay, so I'll erase my drawings. Any doubt or questions on what data science is and what skills you need to be a data scientist? Okay, so this should give you, this should actually set the benchmark for some of the questions or the expectations which a good number of you had in the beginning of the class. I just want to end the show for a minute. I'll again start the slideshow. The reason I want to end it is I just want to look at some of your questions here which you put in the Google document or in the chat box. Anything to related which I have not covered yet. Okay, Abdul has a question. He says, in your institute, will you cover R programming language as a whole? Yes, Abdul, we do cover R programming language, but Abdul and the others, okay? Please do not come and do this course with the intention of learning a programming language. This course is meant to teach you data science. We will give you the fundamentals of programming language, but for you to develop expertise in R or expertise in Python, you either have to do a course in Python separately or you need to develop on your own. This course is meant to teach you data science. And as I mentioned, to do data science, you don't need to be a very big expert in R or very big expert in Python. You do definitely need to pick up the basics. On a scale of 1 to 10, you need to be at a 5 or a 6. And with practice, programming is something which is very much driven by practice. The more you put, the better you'll be at it. Right? So, Abdul, did I answer your question? So, R we will be covering, but don't expect to be in detail coverage. We'll cover the fundamentals and start taking you through the machine learning things. Okay. So all of you guys know this, like right now decision making in business world is all data driven. We are no longer, it's going to be driven through intuition or anything like that. So data analysis is what is actually driving decision making in today's world, right? So only God we trust, everyone else needs to bring data. And then this is again a summarization of what I've already explained. Data science is nothing new, it's an old concept, okay? It has been around right from 1940s or 60s. If you look at the financial services industry, they were using data analysis and data science in some form or the other right from 1960s in predicting what investments to make in the stock market, in predicting what kind of customers to give a loan to. So probably at that time we were having different words for it. We used to call even business analysis or statistical analysis, but it has been very much in existence. And if you look at most of the machine learning algorithms which you're learning, all these have been conceptualized in the 1960s, maybe support vector machine also in the 1960s, but that was conceptualized by mathematicians in Russia or East Europe, I suppose. So the Western world and the rest of the world came to know about only 1980s. But so from a mathematics perspective, from a science perspective, there's nothing new about data science. It is just that it has become more mainstream nowadays because of three developments. The first and foremost development is the processing power became a lot more cheaper and available to everyone. Today we have very high-end Pentium processors or even AMD processors which can actually do the lot of computation in a fraction of a second. The second thing which is very cheaply available today is RAM. Okay, the RAM of the computers, all of you I'm sure. Your smartphones are having 6 GB of RAM or 8 GB of RAM these days. Computers are going to 8 to 60 GB of RAM. So RAM is again easily available. And the third thing which actually made data science a lot more mainstream rather than something which is very specific to a particular industry or probably to be in the research area uh, is also the generation of data. Okay, today we live in after the internet came and after the smartphones actually came. Today we are generating a lot of data. Okay, and this data is not just internal to the organizations; it's also external to the organizations. And people said, hey, we have so much of processing power, we have so much of RAM which is available, and we are generating all this data. Can we make something useful about this data? Okay, and that's how data science actually was born. And that's why data science became a lot more mainstream. Because today organizations want to compete on analytics, they want to compete on data science, they want to create a competitive edge over their rivals or over the other companies that are in the same industry using data science. But please keep in mind, this is not something old. Okay. Vignesh is asking another question. What is the role of big data and data science? Very interesting question. I'll answer it right now. See, when a lot of data is being generated, okay, you need to handle that large amount of data and then actually start building some machine learning algorithms on it, right? And when you build machine learning algorithms, please keep in mind, you don't build your machine learning algorithm using the entire data. That is a very silly thing to do. You actually sample your data and actually create a sample which is representative of the population. Okay, this is something which we will cover in your probability and statistics, and how you create samples which is representative of the population. And then you go ahead and actually build your machine learning or you do your analysis on the sample, right? So in many situations, in most of the situations, I won't say in all situations, most of the situations, the amount of data which we handle, on which the model is built, or on which the analysis is done, or which the pre-processing is done, which you will do as a data scientist, is typically on a sample of data which represents the population, and the sample is going to be in the form in GBs or MBs, megabytes or gigabytes, maximum going to be in gigabytes. It's not going to be in petabytes or terabytes. But in reality, okay, after you build the model, you will actually have to apply this model in a real-time environment. Let us take a typical example of something like a Netflix and Amazon Prime, right? Amazon Prime and Netflix, they actually keep recommending you movies, right, based on what you have seen. So they do it through a recommendation engine called collaborative filtering. It's a machine learning technique which is based on k nearest neighbors and singular value decomposition predominantly, but there are other techniques as well to do it. So if you look at something like this, to build this model, right, they wouldn't have taken all the customers' data of Netflix or all the customers' data of Amazon. They would have taken a sample. They would have taken a sample as a representative. It might just so happen in this scenario because Netflix and Amazon may be generating so much of data. The sample of data could also be in some GBs, 1 or 2 GB or 500 MB. This could be in that scale. You use the data and you build the model. But after building the model, the implementation of the model, because the model is a machine learning model, as I mentioned earlier, is nothing but a function, Vignesh. So when it's a function is, in other words, is nothing but a program. Guys, can you switch off your webcam, please? I don't know who this is, but he switched on his webcam and is on the bed. Yes, please switch off your webcams, please. Okay, so when you go on to this, when you're applying this machine learning model in real-time environment, correct? It could be in a big data environment. Okay, so as a data scientist, you do definitely need to develop some knowledge in your working environment on big data, but that is specifically in companies such as internet companies and so on. Okay, predominantly to 80 to 90% of your job, you may not be really dealing with big data, but there are scenarios like this, as I mentioned, the Netflix model, where you could be actually deploying a model in a big data environment. But if you take again the same thing for a banking scenario, you're coming up with a machine learning model to predict who's going to respond positively to a personal loan campaign. All your customers who you actually subset and you ask your telecallers to call to could be somewhere in thousands, right? So there it's not really a big data problem. So there are certain data science problems which probably in the learning phase may not be that much big data. Even in the learning phase, big data is only going to be in GBs. But in the deployment phase, it's definitely going to be big data. And the classic example over here is internet companies such as Amazon, Netflix, or Google. So Vignesh, to answer your question, what is the role of big data and data science? And all the others also. I'm sure some of the others also have this similar kind of a question. So in a big data environment, we will actually deploy it like Spark, using Spark or anything like that. Vignesh, if I answer your question, just type yes. Yeah. Or if you have a follow-up question, please type that also in the question answer box. Okay, so there's a small exercise here, but I'll skip it in the interest of time because we have wasted some time here. So let me jump the slides here. So this is also something which I've covered. Earlier, data was isolated and within and present only with companies. And today, data is actually present not just internal to the companies, but it's present everywhere. You need to extend your company's database with third-party databases. Storage is no longer expensive, it's very cheap. Data is no longer isolated, and people are no longer looking at a post-mortem kind of analysis every time, because a post-mortem analysis is what you used to do in the business intelligence world. I don't know how many of you come from that time era when early 2000s and mid 2000s, where we had BI software and we used to generate a fixed set of reports for the customer based on the BI software, and these reports are all like post-mortem analysis. Like I'll generate a report, let's say for a company like Maruti, I'll generate a report, what is my sales, how my sales has been in the last 1 month, how my sales has been in the last 1 week. And I could be doing this at the region wise, I could be doing it at the city wise. So that is more like a post-mortem analysis, something event has already occurred. That is still relevant, guys. I'm not saying it's not relevant. You do generate a lot of insights on that. And data science also believes in doing some post-mortem analysis. But the larger focus of data science is all to do with in generating insights which are futuristic in nature. More prescriptive insights or predictive insights is what we will generate. So short and irrelevant insights which are coming from business intelligence, they are definitely existent, they definitely add value, but people are expecting much more beyond that. Okay? So earlier processing of data was slow because of the RAM which we are given. Now the processing of data is much faster. Okay, Mr. Jayaprakash has an observation. Big data means Hadoop. Big data means not just Hadoop, okay? Hadoop is one of the framework in which you do big data. Please understand, Jayaprakash. There is also Spark in which you do big data, but of course, they won't be covering anything like Spark or Hadoop as part of this course. That could be a different course altogether. Yeah. Okay, so let us proceed further now. I think I already covered this. Traditional BI doesn't make sense. You have petabytes of information now coming from multiple sources, but of course we'll be using a sample of that to actually build the data science model. And this information sources need not be always structured. It could be semi-structured like APIs. It could be log files. It could be text file. It could also be an image file. Okay. So this is what the role of a data scientist is. Typically. Data scientist in the beginning will be an individual contributor role if you're looking from organization perspective. It's not going to be something which is going to involve, it's not going to involve much of people management. Okay, if you're a senior data scientist, you could be handling 2 or 3 junior data scientists. That's maximum amount of people management you will do. It's more an IC role, an individual contributor's role. And the role of a data scientist involves all these tasks. It involves tasks of preparing the data. Okay, when I say preparing data, collecting data from multiple sources. And if you're working for, let's say, you're part of some IT services firm and you're working for a client which is a bank. So for you, when you're preparing data, you could be extracting data from the internal database of the banks. And you could also be extracting data from third-party data sources. Okay, which are like Twitter or which could be some credit bureau information. Like if you take the same example which I'm going to take again, you want to predict whether a person is going to take a personal loan or not, right? And you want to build a model to predict that, a machine learning model, let's assume, or you want to analyze and give some insights on that basis. So you collect data which is internal to the bank, which could be your savings account data. Wherever possible, internal to the bank again, but a different department, you could be getting data from the customer's credit card spend. Okay, when I say credit card spend, what is the outstanding credit card and what is the payment which is doing? You could be getting that as well. External data could be your CIBIL score. Okay, which is the credit bureau which is giving this data. So you could be getting data from your CIBIL score as well. Okay, external data could also be like, his LinkedIn data. Okay, let's assume you are also theoretically LinkedIn has still not opened its data through APIs, but theoretically let's assume you are able to get his resume on his LinkedIn, and you can check how stable he is there in his different jobs which he takes up. So that could be another data which you get. So now you're getting the internal data from one department, which is the savings bank account. You can get internal data from another department, which is the credit card department. You could be getting the third-party data such as the CIBIL score. You could also be getting third-party data from resumes or LinkedIn's. Okay. You could also be getting third-party data on the demographics in which location he stays from the census, right? Talking about the US perspective, I know all the financiers do this. They don't give loans in a particular area. Okay, for what reason they do, we don't know. Because the maybe the crime rate is very high in that area, or the default rate earlier could be very high in that area. So there could also be some location-based census data also which you're getting. Okay. So Ankit, this is a real example I'm taking. You want me to take any other real example? Ankit, I was trying to take a real example and actually explain you this, how data is consolidated from multiple sources. And I'm of the opinion that banking is something which you guys understand. So that's all of us know a little bit of retail banking as such. I can take another healthcare example, but I'll take it towards the end maybe. Now let me go with this banking example because I believe all of you guys understand it. So you take data from these multiple sources and you combine this data from multiple sources and combine it into a CSV file, a comma separated file. Okay. Some of the data like let's say the CIBIL data or the credit bureau data could be coming to you in an API format. Data which is coming from your different departments within the bank could be coming through a SQL database. So you'll have to combine them with a common key, right? And CIBIL also, again, you'll have to look at the keys such as the credit bureau data could be coming from using your PAN card. I think typically PAN card is the identifier of the mobile number. Using them as an identifier, you have to combine them, right? And then based on, you also need to extract data from your resumes. Okay, in terms of how many jobs he has changed from the last 5 years, that could be one data which you put it in this. Or you could also put it like how long, what is the average time which it stays in a particular job. You could be getting it from his resume data or his LinkedIn profile, and you add that as a field. This is a new field which you add, right? And location. Location. Guys, go on mute. I can feel that someone is unmuted themselves again. Okay, who's this on mute? Where's the mouse? Who's this on mute? I don't know who caller 3 is. Maybe that person is on mute, unmuted himself. Okay, let us proceed now. It's again the voice is gone. So you'll have to prepare this data and create a single frame of reference, which is a comma separated file. After you create this single frame of reference, you may have to create some additional variables from the variable which you have already collected. Or you could be actually doing some basic cleaning. When I say basic data cleaning, there could be some records which are missing. There could be some places where you need to calculate a new variable, so on and so forth. So all this is something which you need to do as part of your data preparation and cleaning. Okay, and that takes close to 30 to 40% of your time. And these are my opinions over here in terms of percentage of time which it takes, right? And if you look at it, typically data science initiative is short duration. They're not very long term in their timelines, at least in the proof of concept stage. And an example which I took, like you're building a model to predict whether a customer is going to take a personal loan or not, the business user will expect you to come up with results for this model in anywhere between 1 month to 4 months time frame. The longest which a data science initiative will happen is 6 months duration, but typically it happens in a 3 months duration. If everything is in place, like the data giving, the business knowledge, and the buy-in from everyone, it can actually happen faster. The actual analysis could be lower sometimes. Navigating yourself and getting a buy-in and ensuring that everyone knows it takes a longer time. Okay. So data cleaning and preparation, the task of collecting data from multiple sources, creating a single frame of reference, doing some data pre-processing both from a statistical perspective and also from a business logic perspective. Statistical perspective could be filling in missing values, or some of your records could have missing values, some of it could have the erroneous values, some of them from a statistical perspective could also be the data point is filled up, it's relevant, but not relevant for your analysis which you're building. You're actually looking at personal loan, but you've got data points of customers who are actually in a very high income bracket. You may want to handle them separately, remove them. There's outlier analysis. Okay, all that actually involves in data prep and cleaning, and that is 30 to 40% of your time. After doing your data prep and cleaning, you go ahead and you actually start doing some visualizations, and you go ahead and you start calculating some summary statistics, and you start developing intuition about the data. Okay, you do something known as correlation analysis, you do something known as independent analysis, chi-square test of independence, and so on. And all this is something which is going to happen in part of the analysis stage. Can all of you hear my voice, guys? Is there any problem in the voice? If there's a problem in voice, do let me know. Okay, Vivek said it's clear, and looks like it's clear for most of you. Okay, so we'll continue. Okay, so analysis insights is the next part of it. So which is another 20 to 30% of your time. And then following the analysis and insights, you actually need to come up with some hypothesis, like how you will actually, because you are given some insights based on analysis, you're okay, basic analysis which you're done. And after that, you say like, hey, I can give you some more prescriptive or predictive insights based on some machine learning model which I can build, right? So for building the machine learning model, I need to come up with some strategy on how I'll build the model. I need to develop some hypothesis on the model. Like one way hypothesis actually looks at is, if you go back to my banking example, I want to predict whether a person is going to take a personal loan or not. That is y is equal to, and I have a variable called y is equal to 1 and it takes a personal loan, y is equal to 0 and it doesn't take a personal loan. And I have past records of data where people have taken a personal loan, and I want to learn on that data. And for each past record, I have this other X variables, which I have collected and done it, which is my savings account balance, credit card balance, maybe my civil score, and so on and so forth, demographics such as age, location, which kind of company he belongs to, does he have a salary account, does he have business account. You can see, you can believe that the devil lies in the details, right? So based on this, if you actually now say that, hey, I have close to around 40 different X variables, but I would like only, but the 40 different X variables are not relevant. I have data, but on the basis of my analysis, I believe all the 40 are not relevant, only 10 are relevant. So you frame a hypothesis that, hey, I'll go ahead and build a machine learning model with just 10 of these variables, right? And I believe, and I also come to the strategy on how to build a machine learning model. You might say like, hey, I would like to build a decision tree model, or I would like to build a random forest model, maybe the kind of algorithm which you choose. So that is another 20% of your time, which you actually take over here. And based on the hypothesis, you go ahead and you actually build the model, right? You go ahead and build the model, and once you actually build the model, right? The model once it's built, it's not that it's just a 2 lines of code which actually builds the model and it's all good, and people are impressed and people say, wow, you're giving some creative insights, and again the machine can start taking. It doesn't happen that simply. The model may have a lot of error. The model may actually be fine-tuned. The model may not be performing that well. So it's very iterative. You'll have to again go ahead and see how you can actually fine-tune the model. Okay, and that's where your mathematics knowledge about the machine learning algorithm will actually come in play. That will actually help you on how you actually can fine-tune the model really well, right? So that's another 20 to 25% of your effort. So your machine learning and model building, in case you decide to build a machine learning model, is just 20 to 25%. You do a lot of time on your data pre-processing, cleaning, analysis, and coming up with an hypothesis. And based on this machine learning model which you have built, or even based on the analysis which you have done prior to building the machine learning model, you kind of come up with insights. Okay, that is what I'm saying, making decisions. You come with a recommendation, like, hey, call these customers. In the typical example which I've taken, and for each, and then the business user might either believe your recommendation blindly, okay, and sometimes he doesn't believe it blindly. He says, give me a reason why you believe that we should call this customer. So you again need to give some rationale behind each recommendation. So choosing a machine learning model is also dependent on what the business user is expecting. Is he looking just a plain machine learning model from the perspective that, hey, it's a good accurate prediction, or is he also looking for a reason behind the prediction? Okay, that's known as explicability, which you will have to handle and set the expectation right as a data scientist. Okay, so all this is what your role as a data scientist is, and all this is in the POC stage of the proving that a machine learning model can actually add value to his business. Because here we are directly impacting the top line of the revenue, where we are saying that, hey, we have built a machine learning model which can actually help you to reduce your cost of calling, and also it can also improve the impact of calling. Okay, most of the customers earlier you called 100 customers, only 2 people take a loan. Now because we are using the machine learning model, you call 100 customers, 10 or 12 people actually take up the loan, right? So that's really the entire use case over here. And Vignesh is asking, hey, can you come up with a real-time example in the e-commerce? Vignesh, are you from the e-commerce industry that you're so excited about e-commerce? Okay, so I'll take an e-commerce example which is from Netflix because I mentioned about it and Vignesh got curious about it, so he wants to know about it. So in Netflix, what happens is we all actually go and see the movies over there. Initially, when we actually log into Netflix or Amazon Prime, it asks you to choose the movie which you like, right? Based on the movies which you like, let's say when I logged into Netflix, I like Bahubali. It's one of my favorite movies. I've liked some movies like Shawshank Redemption. Okay, and I also like some animation movies like which one did I like? I like Happy Feet, and I gave some movie which I liked over there. Based on the movie which I liked, what the Netflix algorithm actually doing is, it actually based on the movie which I liked, it puts me into, it finds out what are the other customers who are similar to me, who have liked similar kind of movies or who have watched similar kind of movies, right? Let's say Vignesh, you are the other customer who also has liked a similar kind of movie, right? And here again, the data which is being taken by Netflix is predominantly the internal data because, and the data which they have is what kind of plan which you have taken, whether you are on the premium plan, whether you're the basic plan, okay, and they also might have data on how are you actually seeing this movies. Are you seeing on a mobile? Are you seeing on a desktop? Are you seeing on a TV screen? Okay, they have all that information over there. They also might be having additional information on you, like in terms of which location are you coming from? Are you from India, Hyderabad, whatever, right? They have all those different kind of parameters on you. So they can actually figure out your similarity with other users based on your user parameters like location, plan, and whatever. But what they do predominantly is based on your transactions or the kind of movies you like. And let's say you also have seen similar movies and or you like similar movies. So they will understand that Vignesh and Shravan are similar, right? They believe that both of us are similar, and based on both of us similarity, the machine learning algorithm also figures out that Shravan has liked Bahubali, Happy Feet, and these, and he has seen a couple of other movies. Vignesh also has similar movies and he's liked the same kind of movies, but Vignesh has also seen another set of movies which Shravan has not seen, right? So now since Shravan and Vignesh are similar, there's people who have similar tastes in terms of movies. So let me recommend Shravan the movies which Shravan has not seen but Vignesh has seen, right? So that's how a Netflix recommendation happens. Okay, at a very base level, that's what it happens. A second letter in recommendation is also on the basis of the kind of movies which you have seen and what you like. In that category of movies, they can actually give you similar kind of directors, or because each movie, we know the language is similar, we know the director is different, we know the genre of the movie is similar, and recommendation can also happen in that front as well. Okay, Vignesh, I cannot go on further many more examples, but hopefully you are able to reflect on this Netflix example, which probably you have also seen as a customer. Hopefully, Vignesh, does that answer your question? Okay, so let us proceed further. Okay, so this is just something which I've already mentioned earlier, right? Earlier era of business intelligence or data analysis, it was more prescriptive and looking backward. Data science more looking forward and predictive in nature. We used to mainly handle structured data to a limited extent, semi-structured data. Here we are handling only, we handle definitely structured data, but we'll have to extend it with unstructured data, non-numeric data. Data is mainly reporting. Here we are exploring, discovering, investigating, and visualizing. These are short-term investments. Like typically a data science project is, it could be something as low as investment for companies in the US, $150,000 to something like $350,000 or $400,000. That is how the investment in a data science project is. Okay, voice is not clear. Graphics is saying voice is not clear. Is my voice clear? Others, please also verify. Manisha says yes. Okay, let us just see this. The voice being clear is a function of two things. Of course, it's a function of the bandwidth which Prime Class is having here over in their office. That I'm taking from Prime Class's office today's session. It's also a function of the bandwidth you guys have at your house or wherever you're seeing this. Okay, so Manisha, Kirti, George are saying it's good. So I'm assuming for a good set of you guys it's good. So graphics, just look at it. So data science is more reproducible once you actually prove the concept. It is actually deployed in a real-time environment. Like the Netflix example, I could be building this model on a sample of customers. After that, every new customer, I'm actually going to figure out this customer is similar to which kind of customer in my sample. And I know the sample of customers are actually liking these kind of movies or this kind of particular profile, and I keep giving those recommendations. So it's reproducible. Okay, it's reproducible. We can sometimes do the same data, different analysis, and the same model is deployed. It can keep generating results. But of course, we have to monitor the performance model. Like I'm sure Netflix monitors the performance of the recommendation engine constantly, and they keep coming up on ways to improve their model, which we will see in a minute. And typically, the programming languages where machine learning is done is R or Python. Probably in some of the edge cases where big data is used, you could also be using Hadoop and Spark, where we extract data from where you deploy the machine learning model in a Hadoop environment, or sometimes there's a large amount of data is generated and Hadoop is a store for it. You'll also be extracting data from a Hadoop environment. Okay. Let me go to the next slide. So data science is actually growing. Okay, there are two lines over here, the red or orange line, the blue line. The orange line is the growth of big data jobs. Okay, that's also growing and it is picking up, but that's like more like a scalar or a linear growth or slightly little bit non-linear. But if you look at data science jobs, the blue line, it is completely a non-linear growth. So the reason why it's happening is more and more organizations want to utilize their internal data and their external data, and they're looking at data scientists. And data scientist doesn't necessarily have to be um, building machine learning model or every now and then. It could also be a lot of data analysis which you're going to be doing. And there's a dearth of jobs over here, a lot of requirement of data scientists. And in India, based on Indeed, the source of this data is Indeed. Typically, someone who is a fresher or has probably less than 2 years of experience, he starts off on a package of 6 lakhs per year. Okay, that is the package he starts. But if you are an experienced person and you are developed your credibility that you're a very good data scientist, I know data scientists who are even earning anywhere in India, sitting in India itself, 60 lakhs per year to 80 lakhs a year. Okay, an average probably with experience and freshers, it could be around 25 to 30 lakhs. So this is a place where you will, the salaries are pretty good and excellent and a lot of opportunities. And I think there's money to be made over here if you pick up the skills in the right way for the next 3 or 4 years. Any questions, guys? Okay, because I just want to reconfirm whether any questions, because you guys have spoken as a monologue here like Narje continuously. I am not sure how much you guys are getting it, and at least if some of you can confirm whether you understood, right? If you don't have any questions, I know it's a large audience here, but please. Okay, so looks like no questions, no one is saying anything, and looks like people are understanding. Let's go to the next slide. So we'll do one thing. Let us take a break now. I think the time as per my clock is 12:17. Okay, that is my cell phone, but yeah, 12:17 is the time as per my clock. So I'll go on mute for 5 minutes. We'll start the session again at 12:22. So during this time, guys, please feel free to take a bathroom break or whatever you guys want to do. Maybe have a sip of water or breakfast or anything, and come back after 5 minutes. And probably some of you, if you feel that you have questions during this 5 minutes, you can just write those questions in the chat box. So let us take a 5 minute break and we will again circle back at 12:22. I'm going to go on mute in this 5 minutes. Okay, so guys, please don't panic. 5 minutes. And out of 5 minutes, we will continue the session. Suhas is asking this, and we'll conclude the session in half an hour, maximum half an hour after the break time. It could be shorter than that, Suhas. So please keep yourself available for the session till 1 p.m. Okay, that's my request from my end. And it will, anyway, you guys have taken out time, just take out time another additional half an hour. Okay. Thank you guys. I'll just go on mute for a minute. For 5 minutes, sorry. Okay guys, I'm back. Can you guys hear me? Maybe Suhas or someone or Tanu can actually confirm if you guys can hear my voice. Yes, Kirti has confirmed she can hear my voice. And secondly, one of our organizers have actually shared another Google form. Apologies, guys, there are two forms over here. And I suggest that all of you fill up this form, which has been okay. I need to copy this link and share it. I'm doing that because we have reached the later half of it. There's another Google form I'm actually sharing with you guys. One second, guys. Let me just share it with you. And yeah. So I have shared one form with you guys. You can see the link over here. And please click on this form. And since we reached the last half an hour, anyway, I'll be taking you guys through it. But please take out time and fill this form. And let me just show you this form to all of you, so you guys know what this form is. 1 minute, guys. Okay, this is a very simple form like this. Hopefully, you guys can see the form over here, where you need to give your name, your contact number, email ID, probably a designation, how do you hear from us, and what is your preference. Okay, I know some of you are not from Hyderabad, we are based in Hyderabad, so for you guys it will be online regular. The different regular and weekend is regular is going to be your Monday to Friday batch, which is going to be on mornings only. That's what I think, but they will communicate the time again to you. The weekend is going to be on Saturday and Sunday. Again, it will be in the morning only, probably 10 to 1 or something like that. So choose your option, what is suitable for you guys. And if you want to undergo training, and do give your name, contact number, and email ID. And that will be really helpful. There's a small printing mistake here. I think ID got auto collected here. Just it means the email ID. Okay, guys. And just express your interest, and people who are interested will probably the client team will actually get back to you guys and reach out. People, if you guys believe this, you don't have interest, just tell the same to them, and they will not trouble you. Okay. So I request you guys to express your interest through this form. Thank you, guys. Now let us go back to our slides. And I will conclude now with a small another use case. So before I conclude on through a use case, the next half an hour, I want to tell the responsibilities of data science again. This is something which we have covered, but I would like to cover it again. So you need to be very abreast with what is happening in the industry, the state of the art knowledge, right? So probably what I teach in this course is relevant, but 1.5 years down the line, there could be some new developments. Okay, because just to give you an example, year and a half back, when I used to cover regression, I only used to teach linear regression, which is one of the most popular machine learning techniques. But these days, we also touch upon something known as the ridge regression and lasso regression, which are extensions of linear regression. Okay, 2 years back we only used to teach neural networks. Now we have extended it and giving you foundation in deep learning as well, right? So developments keep happening. 2.5 years earlier, when we used to teach natural language processing in Python, we only used to refer to the NLTK library. Today we also refer to something known as STACY, right? So developments keep happening, and you need to be abreast of the state of the art and extend it. Secondly, extend your knowledge. Secondly, as I mentioned earlier, you need to extend the company's data sources with third-party sources of information. This could be information which is freely available in the public domain, or these could be information which your organization is purchasing at a cost. So that is required. Third skill which you need to develop is you need to extract data from these multiple sources. You need to clean the data. You need to process the data. You need to verify the integrity of data. When I say verify the integrity of data, is it a missing record? You drop it or you fill it up? Is it a missing record because of human error? Is it a missing record because of some problem in the data extraction process? All that you need to verify and actually ensure that happens. Fourth and most, okay, you either create an insight generation system or you create an anomaly detection system, and you need to constantly build a model which is acceptable to the business. You need to deploy the model, and after deploying the model, you need to constantly monitor its performance. That is your job as a data scientist. I'll talk about the deployment and monitoring in the subsequent slides. Lastly, you need to also select features. When I say features, okay, I need to draw something now again. Mouse. I said machine learning is all about building a function y is equal to f of x. So there could be cases when the number of attributes, when I say attributes or features, I am referring to this X attributes, the X variables. If you go back to my banking example, it is nothing but your saving account balance, age of the person, the location of the person, the credit card outstanding, and so on. So there could be several attributes. Okay, typically in some internet use cases, you may have, or at least bioinformatics, with respect to data science is done with respect to genes. The attributes x1 and so on could be 500 or 1000 in number. So you as a data scientist should be knowing all the tools and both the programming tools and mathematical techniques to reduce the number of features and select the correct set of features. Okay, from 500 you need to probably select 50 best features. So you need to learn those skills as well. You need to go ahead and build and optimize a model, and you need to do this with a variety of algorithms. First, you need to choose the best algorithm possible, and sometimes even you believe that you go with the best algorithm. You can you want to experiment with other algorithms also, right? So all these are your responsibility as a data scientist, which you need to do. Okay, let me clear these drawings. Let us go to the next slide. And this is the life cycle of a proof of concept data science project, and also going forward. There is a data acquisition stage, there is a data preparation phase. Okay, when I say data acquisition, you acquire data from multiple sources. You prepare data and create a common frame of reference, a CSV file, right? And then you, after acquiring the data, you analyze the data, and after analyzing the data, you visualize the data. Based on analysis and the visualization, you come to some hypothesis and how what kind of models can be built and what model to actually build. You go ahead and build the model. After building the model, you actually evaluate the performance of the model. Basically, evaluate the performance of the model whether it's accurate enough. Going back to my example, you build a model to predict whether a customer is going to take a loan or not, right? And then let's say the accuracy is pretty poor. How can you actually interpret it? And also based on your model, you are getting some insights on the customer. The people who are actually responding positive to the loan campaign are people who have high credit card bill, are people who come from a particular class of companies. That's a very beautiful market insight which you're getting from the model, because they are compliant to the model and the model is telling you like people who responded to the loan campaign are people who follow this particular pattern, right? So that interpretation of the insights of the model can be communicated to the business users. So here the business users are the retail marketing team or the personal telecalling team, and they can actually say, hey, okay, let us take this insight and let us start acting upon it, which is calling these kind of customers. So the evaluation and interpretation is very important. And also in the evaluation interpretation stage, there is super critical, this is where your business analysis skills will come in, how you actually set the expectation with the client, and based on the expectation which you set with the client, right, you actually, based on the expectation you set with the client, you figure out the accuracy levels of the model which is acceptable to all of them, and based on the accuracy level which is acceptable to all of them, and if it is got a clean tick mark and everything, you deploy the model. You deploy the model in action environment, like just like how Netflix has deployed the recommendation engine model. And once it's deployed, you continuously monitor the performance model, and if there are any places where the model is not actually performing that well, you figure out how to improve the model, or you say like, hey, let me scrap this model and build a complete model again. So let us take this through a small use case, a very small use case, which is a real estate example. Let's say there is a real estate marketing manager, operation manager, or head of a real estate company. He wants to predict what is the baseline pricing which he has to do for his apartments, and he comes to a data scientist and he asks him to help him with that. And going forward, so there are different phases over here. Data acquisition, you'll see for this example of the real estate, where the real estate company wants you to find the baseline pricing. What are the different phases over here? What do we do in the data acquisition phase? What do we do in the preparation phase? What do we do in the hypothesis phase? What do you do in the evaluation phase, deployment and operation phase? So let us see this. First, we acquire data here. You can see the first four columns, which is the price of the apartment, previous price of the apartment, and which got sold, the apartment number or the name, the number of bedrooms, the floor number is actually coming from the internal database of the company, right? So this is coming from their SQL database or whatever database which they're actually keeping over there. Then we have criminal rate per year. this could be coming from census data. And as a census data, this could be coming from looking at the US perspective. The US is an economy where data is actually stored from everywhere. In India, we may not have this, but US, they have each location, what is the crime rate actually applicable in that area. They actually have the data for that. So crime rate is something which is coming from census data, which is third-party data. Pollution level. This could again be coming from a third-party data. Okay, in the US context again, this could be something like a environmental and protection agency. There's an agency called Environmental Protection Agency in the US, which sets up this pollution meters. I think in India also they've started, which actually give the air quality index of each and every area. So that could be the pollution level. And lastly, we have distances, and distances would be from education institutes, distance would be from hospitals, and this is data which you get from Google Places API. Okay, Google Places, you can actually, you know the lat long of your property, and based on the lat long of property, you find out the nearest distance to the nearest school or the nearest hospital, and that distance is actually given over here, right? So you have third-party data like Google data, you have third-party data like US Census data, you have third-party data like environment protection data, which you're combining with the internal data and creating a single frame of reference, a CSV file, and which is in a tabular format like this, which you have to do as a data scientist. Okay. After that, you also see that there is some record which are missing. Pollution level could be missing for some particular apartment. The floor number is not following the same units. Like in some places, the floor number is written as 0. Some places, the floor number is written as G. Okay. And sometimes the column name could also be too long. You may want to reduce the column name, right? So there is some basic data pre-processing like this, filling in missing values, bringing all of them to the same units, and also taking care of outliers, which is what you do in the data preparation phase. Okay. After preparing the data and unifying it, you may convert the data into CSV, JSON, whatever. You can do the pre-processing before, you can do the pre-processing after, taking in a CSV format. It's up to you what you do. You actually do that. And then you do a lot of analysis on the data. Analysis could be figuring out some statistical measures like mean, median, mode, and analysis could be to do with a lot of visualization. Analysis could be something like correlation analysis. Analysis could be something like test of independence which you apply. Analysis could be something like figuring out the information gain of each variable. These are all techniques which we taught, which we teach you as part of this course. Based on the analysis, you come up with a hypothesis that hey, let me actually only take 3 variables. These 3 variables are good enough to actually predict the price. And this is an example which you have taken, and the 3 variables you choose is number of bedrooms, criminal rate, and pollution, right? And you want to build a machine learning model for it. And machine learning model, as you guys are aware, is nothing but a function. So price is a function of these 3 variables, what you're really looking at, right? So you go ahead and you go ahead and build this machine learning model in Python, R, or Spark with this large amount of data. So you need to write a program to extract the data, clean the data, build the machine learning model. And you build the machine learning model because whenever you take your data, you divide the data into training set and test set. Okay? So because you learn the model or you learn the function of the training data, because typically you take 100,000 records or 100 records, just to give an example, 70 or 80% or something like 60%, this again a data scientist decision, is the training data which he uses to build a machine learning model, and the remaining 30% he typically uses the test set on which he evaluates the accuracy of the model. Because, and this test set is something which you should not use to develop your analysis, and this test set is not something which you use to understand the accuracy of your model. So this is a set of data which is used by you and your client or you and your sponsor to figure out the performance of the model. Okay, so you do it in the test set and figure out it's accurate, and let's say it's accurate, it actually ticks off all the marks and the expectation which you set to the client. After it has ticked off all the marks, you actually deploy it in the real-time environment. And typically, when you deploy it in a real-time environment, it may not be in the same environment in which you develop the model. You may have developed the model in R and Python, the real-time environment could be in Java. So you need to have a little bit of interaction here with the engineering teams on how to deploy it in a real-time environment. And which is not really a major challenge. And after deploying a real-time environment, right, you continuously monitor the performance of the model. Is the model giving the right price? Is the model not giving the right price? In terms of Netflix, is the model giving the right recommendation? How do you know whether in Netflix the model is giving the right recommendation? If many of the users are acting upon the recommendation and actually liking the recommendation, seeing the movies the recommendation is doing, is giving, sorry, the model is giving as a recommendation, then of course the model is performing well. But if most of the users are not liking the recommendation which the model has given, or if most of the users are kind of seeing some other movie which seeing some other movie which is not given by the recommendation, that means the model is not performing well enough, right? So in such scenarios, what do? We actually go back and say, let us rebuild the model, or we can say, let us improve this model further. And improvement of this model further could be one way of improving the model. Just to give you an example of the many multiple ways in which you can improve the model. One way is we add a new factor. Earlier we only had criminal rate, number of bedrooms, and what do we have? Criminal rate, number of bedrooms, and pollution. Okay, now we might say, like, let us include distance from a school as part of the model, as one of the attributes which will actually go and build this model, right? So you can actually also build that as well. And after it is retrained and re-performed, re-optimized, again you deploy it. So this is like a continuous stage, and as part of this effort, not only are you predicting what is the price at which the real estate firm should actually be above which you should actually sell the properties, they are also giving them a lot of insights which could actually help them in improving their business model. So this is typically an example of a very, very high level, a very simple data science project, how it will happen. And you can think of similar kind of situations and examples which you will come across. Okay, Ramachandran is asking a question. He says, can you please share the PPT of this webinar? I'll check with the team. The team will get back to you on this, Ramachandran, whether they will share the presentation or not. That's up to them. I'm not the decision maker in this. Yeah. So this is what a typical data science initiative really looks like. And of course, as I mentioned, there needs to be some software skills, programming skills which you need to learn. You need to develop some maths and stats skills, and you need to develop some machine learning skills, which is a combination of stats and maths. Apart from this, you also need to develop some business knowledge for you to be a good data scientist. Just to conclude, what is machine learning? I think you guys would have understood. Machine learning is all about constructing a function, and we human beings learn from experience. When computers learn from experience, they're actually, in other words, learning from data, and that is machine learning. Typically, just to give an example, most of you in a typical programming environment, when we write a program, in the most of the things we write a set of instructions. The computer blindly follows our set of instructions and it sees some data and gives an output. Machine learning is a bit different. Okay, I just need to draw a little bit here again. So machine learning, we write again a set of instructions by humans. We write a set of instructions. Okay, and we are given data, which is typically called the training data. And based on the set of instructions, using the data, the computer develops a function. Okay, a function, in other words, a function of the form x1, x2, which is nothing but a program, a computer program. It's called ML program, machine learning program, machine learning model. You keep hearing these terminologies. The next time what happens is this machine learning program or machine learning model is nothing but a set of instructions. Instead of set of instructions written by a human being, the machine has generated a set of instructions which is nothing but a mathematical function, which it calls a machine learning program. Okay, so now here it has learned, and how it has built this program based on data. And using this machine learning program, a new set of data, which is called the test data, or maybe it could be your actual environment. Okay, in Netflix is the real time data which customers are giving through transactions in terms of movies which they're seeing or in terms of movies they're liking. Right, so you get a new set of data. Based on this new set of data, this machine learning program gives some output. In Netflix case, it is the output could be a set of recommendations very specific to the user. In the banking use case, which I told you, is nothing but a set of customers who the telecalling team should actually call. Okay, so the output will be that. So in traditional program, is nothing but a set of instructions, and the computer follows blindly a set of instructions, acts upon data and gives output. In machine learning, again, we do write a set of instructions. These instructions the machine uses on data which we give at training data, and it develops a function which we call as a machine learning program, machine learning model, but in a sense it's actually a mathematical function. That machine learning program acts on new set of data and gives you the output which is required, and this output could be in different scenarios, different things. As I mentioned, for Netflix, it could be a set of movies which are given as a recommended to the user. Okay, so that is how machine learning is different. Okay, Vishal is having a very nice, interesting question. He says, as per my knowledge, I have a list of 74 ML algorithms. Out of them, how many are you going to cover? Vishal, please understand, if you take some technique like linear regression, there is simple linear regression, and there are 10 different linear regressions which are possible. Decision trees, again, there are 5 or 6 different types of decision trees which are possible. Okay? So we won't be able to cover all the 74 for the money which you pay in this 3 months time frame. We'll be covering close to 15 algorithms, the basic algorithms, like the basic decision trees in detail. Okay, you will be actually able to apply it, and these are algorithms which you can even apply in competition and actually a business scenario. Variations of this algorithm is something which you guys can pick up. Okay, we're covering close to 20 algorithms over here. I don't know what your list of 74 covers. Okay, I don't know from where you have Googled it. It's good to Google and get a set of knowledge about what you guys can expect from it. But please understand, this course is meant to teach you the mathematics and the basics of each and every algorithm. The variations of each and every algorithm you can pick up. See, decision tree can be built by CART, decision tree can be built by C4.5, decision tree can be built by C5.0, decision tree can also be built by chain, decision tree can also be built by variance driven. Okay, these are 4 or 5 which I will be covering. Now, apart from this, decision tree can be also be built with by 10 other ways. We won't be covering all of those here. So the 74 ml which you have is a list of many such things also, which are nothing but variations of your original algorithms. So we are only going to cover the predominant main ones, and maybe the people over here can share the brochure with you for the advanced course. And looking at the brochure, you will get a feel of what are the algorithms which we are covering over here. And Vishal, my suggestion is, machine learning, data science, all this is very intensive, okay? And your learning doesn't stop with this course. Your learning actually has started with this course, and it only continues beyond this course as well. In your job also, you need to keep picking up all this additional knowledge. My course is meant to give you the foundation in mathematics and programming and everything. So you have a very strong foundation to do what is required in your job. And if you have to do something what is new in your job, which probably is not covered in this course, even that you can pick up based on the mathematical and the programming knowledge which you have developed here. Okay? So Vishal, does that answer your question? Okay, so let me erase these drawings. I am reaching the end of my session. A couple of more slides I have. I know some of you are wanting to go for lunch, but yeah, let me just take a couple of. Yeah. So data science applications are several, and some of you will be aware. These are just to name a few, and just like how Vishal has 74 applications, I'm sure the number of data science 74 algorithms, the number of applications could be infinite. That's what I would like to say. But these are some of the popular ones which I have covered. In pharmaceutical industry, fraud detection, clinical trials, drug development process, healthcare, non-compliance with taking of drugs. We did a very interesting healthcare example for US in my previous organization, where we are doing intelligent alert system, where we are predicting which patient is actually going to end up in an emergency room situation. And our target set was predominantly we are looking at patients suffering from chronic healthcare problems like diabetes, asthma, hypertension, and based on the health parameters, based on the lifestyle parameters, based on the environment parameters, we were predicting a probability by which each patient can actually end up in an emergency room situation. So healthcare has a lot of interesting use cases. Very interesting industry. I think data science is going to have a major impact there. Banking and insurance or financial services for that matter, they have been using data science right from 1960s or 70s. It's not something which is new. They have been using it quite a lot in deciding the optimal portfolio of stocks, fraud detection, credit scoring, cross-selling, upselling of products, everything they've been using it. Okay, travel and hospitality. As a startup, I'm working predominantly in travel and hospitality. We are working on an AI-related problem, how to improve the customer experience, both before you become the customer over there and after you become. So that's an area which I'm actually working very actively now. Politics, you guys know, predicting of winners, identifying fence sitters, retail, telecommunication, retention, supply chain efficiency, government, policy planning. I don't want to go to all these applications, but there's quite a lot. There are a lot of IoT applications as well. Okay, IoT means I'm not saying we are going to teach IoT over here because I did get this question when I showed this slide. But the impact of IoT will actually come in through AI or data science because IoT is nothing but all the sensors which are actually capturing information and giving to a decision analysis system. The decision analysis system could be an AI system or it could be a machine learning algorithm which actually reads this data from sensors and takes decisions based on that. Right? One simple IoT application could be very simple application, but very hard to implement, but simple in concept. Right? You have this video cameras set up at traffic signals. The video cameras can actually keep taking the images, and based on the images the video cameras are taken, we can understand the flow of traffic. Depending on that, we can change the timing of the traffic signals accordingly dynamically. Okay, that's an IoT application. Another IoT application, which is probably which we will see very soon. Okay, nowadays you would have noticed there are Ubers and Ola cabs which have a advertising panel on the top in which they are actually on the digital panel they keep showing you advertisements. Right. Another interesting IoT application would be depending on the time of the day and depending at which location the cab is, the panel can show different advertisements. Okay. Probably in a location like Banjara Hills, it can show you advertisements of shops and outlets over there. And depending on something like, let's say, someplace like Dilshuk Nagar, the advertisement which is getting displayed on top of the Uber cab, the panel will be different. Okay, so this is very much possible. So this is another IoT application. So a lot more IoT applications are possible, especially for the government. They can use IoT applications to detect terrorists, attacks, frauds, and everything. Okay, huge application over there. And to conclude, this is my last slide. But after this slide, I'm sure people from Prime, the organizing team, they're going to spend another 5 minutes with you. And to build your career as a data scientist, to just conclude, you need to have some good maths and stats skills. You need to develop some programming skills. You need to develop some business communication skills. You need to be very having a inquisitive set of mind and ask the right kinds of questions. And some of you have asked this question, hey, I come from an MBA background, does data science suit for me? Yes, it does. But please understand, you need to have this aptitude towards mathematics. And of course, you need to enjoy mathematics till probably class 10 or class 11. I don't expect you to know advanced mathematics. Whatever advanced mathematics beyond class 10 or class 11, you need to know. We'll teach you as part of this course, but you need to enjoy mathematics because this course will be intensive mathematics. You need to not be averse to the fact of programming, which is what you need to do. And you also need to have a good inquisitive set of mind and a sharp bent of mind to ask right questions. And you need to also have a research bent of mind to actually dig out information wherever it's required which you don't know. Okay, because the role is known as data scientist. The word scientist talks about research and what digging of information coming out with some methodologies or processes to generate insights from data. So that is super critical. Okay, so this is what you need, and you need to be communicative. Some of you, if you don't have good communication skills, start developing that. You need to ask the right questions. Okay, Mr. Vishal is again done some, is asking with respect to Python. He says, hey, are you covering NumPy, Matplotlib, SciPy, Pandas, sklearn, such kind of libraries? Yes, if it is course going to be taught in Python, we will be covering those. If the course is taught in R, there is an equivalent set of libraries which are going to be taught. So these are libraries, Vishal. I think you understand that. The beauty of using the libraries, you don't need to know how to use the libraries, you don't need to come to this course. Trust me on that. Like to know what commands to use in NumPy, you don't need to come to this course, you can actually see a video and do it. What you need to come for this course is to understand the mathematics behind each and every of this and how to apply it in the right way in the right time. Okay? Please come to this course only for that. If you're coming here to learn the syntax, don't come for this course, Vishal. This is something which I want to tell you upfront because I know that you are someone who has dug up a lot of knowledge, but please be clear on what your expectation is here. Right? So this course is not like going to teach you syntax, and this course is not saying that hey, there's a checkbox I covered this library. This course is meant to teach you something deeper, which you want to the mathematics behind each and every machine learning algorithm, the programming behind each and every machine learning algorithm. and how to actually develop deep analysis skills over there. This course is meant for that. Okay, it's going to be like a case-based approach, and it's going to be a bit mathematical approach which we're going to follow over here. So Vishal, hopefully I've set the expectation with you guys. Any other question, guys, before I conclude? Because I have concluded finished my slides. Any other question? Okay, so if there are no other questions, I will ask Rameshwar to actually speak, and he can take over. Rameshwar, please.
Hi all, thanks for joining us and making it a great event. Please, I mean, all of you be on mute. Okay, I would like to give like a 5-minute glimpse of how this course is going to be run and how we can help you out and all that. So this is like a 4.5 month training program. I trust Shravan has given all the information, what's going to be covered and all that. And we are thankful to Shravan and all other team who are like working professionals. These are like practitioners who are running their own firms in the AI and ML space. So I mean, the whole idea of creating this course is to give experiential learning where we can make you meet the industry demands, not like academic knowledge and all that. Now this course is going to be like for 4.5 months, and for the people who want to learn, and what we can do is we are running weekend batches and morning batches. These are the batches we are running. And further details will be given by our executives who will call you, and the career advisors will tell you how the course is going to run and all that. And apart from that, okay, if you are a working professional or a fresher, if somebody is keen on learning this course, we can support you with like a free education loan. Okay, this is going to be 0% EMI education loan. We got a tie-up with an NBFC, which are like supporting us in this venture. So people who are interested, I mean, people can, like fill that form which we have shared, and that's all we want to say. And definitely, I mean, as I said, okay, this course being run by eminent practitioners like Shravan and other people, we believe we are going to deliver the best in the market. Okay. Thank you all once again. That's it.
Thank you, guys. It's been a good session. And apologies probably if we started late in the beginning because because of some technical glitches, and we intend to start 10:30, but we started 11. Hopefully, that's not really an issue over here. And look forward to interacting with you guys again. If some of you guys are going to join online, if some of you guys are going to join offline, I'm sure I'll be more than happy to meet you guys in person. And let us start this journey of you guys picking up this, and probably we can collaborate and work also in the future. Thank you once again. With that, I would like to conclude the session. And thanks a lot once again for taking your time and attending the session on a Saturday. Thank you.